Okay guys, so today we have a bit of a longer video. There's a lot that's going into here, so try to keep up. Again, I'll have timestamps in the comments or in my description. So jump around that. If you need to rewatch any sections or if you just want to watch one sections, try out the homework, then come back. That's totally fine as well. Just use the video to your advantage. I might be splitting things up into multiple videos later. But let me know what you think is better. Would you want one video per worksheet or per quiz? And that way you just know exactly where it is and I just put timestamps so you can tell which one's which. Or would you rather have like every single time I go through a part, I cut the video up? It'll be the exact same content. It's just that the videos are cut up. So that way you just know, okay, I'm done with part one. I should go take the quiz. It's up to you guys what you think is better, what would help you guys out. But let's not waste any more time. Let's jump right in. Let's not make this long video longer. So here's what we got. We have quadratic functions and equations. So now we moved on from the really basic quadratics, and now we're moving on to about applying them a little bit more. Here's what we're going to be talking about in this video. There's three major parts. Number one, we're going to be talking about quadratics, what they are, how to graph them, and how to read the graphs and do some really basic word problems. Secondly, we're going to be showing you how to solve super basic factored form quadratics using zero product property. And finally, we're going to show you how to graph from the factored form. So today we're working with the factored form. That's where we have those little parentheses like this, parentheses x plus 1 times x minus 3. This is factored form compared to something like this, x squared minus 2x minus 3. This is standard form. This is factored form. So today, this is the one we're working with a lot more. So let's jump right on in. So first off, let's talk about what quadratics are. There's a difference between quadratics and linears. When we're working with quadratics, that's when we have a squared in our equation. So that's this bottom one. Linears was these here. We never really called them linears. We just called them equations because there was really only one type of equation at the time. But I always said, hey, keep in the back of your mind, these are called linears. And the reason they're called linears is their lines form, or their graphs form a line. Quadratics now form this shape called a parabola. And let me show you how it's a little different. So here I have a table where I'm showing you guys what happens when we plug in the same x into these two really similar equations. One is a linear and one is a quadratic. So if I plug x into y equals 2x, so I'm going to get y equals 2 times 1, which gives me 2, which is how I got this number here. And then I'll get 4 if I plug in 2. And I'll get 3 if I plug in 2. Or if I'll get 6 if I plug in 3. Hello. So that's kind of how we do it. And what we notice is each of these has a standard growth of 2. Every time I increase my x by 1, I increase my y value by 2. That's a linear graph. However, when I'm doing quadratics, it totally changes it. If I plug in 1, I get y equals 2 times 1 squared, and that turns out to be 2, which is normal to start. But then if I plug in the second one, y equals 2 times 2 squared, here's what happens. 2 squared is 2 times 2. 2 times 2 is 4. So I have y equals 2 times 4, which is how I end up with 8, which is a lot bigger than 4. It's twice as big as 4. And then when we move on, we're going to get 18. We're going to get y equals 2 times 3 squared. And 3 squared is 3 times 3, which is 9. 9 times 2 is 18. So that's how we get this number here. So as you can see, the numbers grow a lot bigger and there's no set pattern. This one grows by 6 and this one grows by 12. You can kind of make a case that says, all right, each time it's growing by another factor of 6, so then the next number will be increased by 18. There are certain patterns, but it's not quite as uniform and nice as your first one. Now, because of that, my graph is going to look a little bit different. So this is what's called exponential growth. That means after every single time I increase my x, my y is getting even bigger. The increase or the gap between my y's is getting much larger. So if you see a squared or a power of 2, so I something like this, y equals x squared minus 3x plus 4, you know that this is going to be a parabola. Y equals 2x minus 7 plus 3x squared. This is a poorly organized one, but it's still going to be a parabola because we see this squared, this power of 2 on my x over here. Now, if I wrote something like this, y equals 3x plus 2 squared, this doesn't count because we're saying, are we squaring the x? Again, that's how we know it's a quadratic. That's how we know we're getting a parabola. All right. So this is kind of how our parabolas look. If we were to graph out our parabolas, now if you remember, the way we graph is we just say, what is the x? If I choose any x I want, what's the y going to be? And these are our solutions. If I chose x equals 1, turns out for this one, my y is going to be a little bit over 2. If I choose my x to be 2, looks like my y is going to be about like 6 or 7 or 8. If I choose my x to be 0, my y is 0. So again, all of these points here aren't just randomly thrown on the graph. They're saying using the equation that we have, which I didn't give you an equation here, these are the numbers we get. So these are our two options here. Either parabolas look like this, up U kind of shape, this kind of skinny U, or this upside down U, or like a rainbow. It can be a little bit wider like this as well. It can be really, really skinny. It just depends. But basically what's happening is it starts heading towards a point. Once it hits a specific point, this point here and this point here, then it's going to turn around and start going back the other way, and they're going to mirror each other. There's something called symmetry, or this mirroring property that happens, saying we're going to go down, and then we're the exact same way we went down, we're going to come right back up after we hit that point. These points here are called your vertex, or your vertices, plural. But this is the general idea of what parabolas look like. So when I'm talking about parabolas, in your mind, you should be thinking it's either a U or a rainbow. All right. So in order to graph a line, you just need 2 points. In order to graph a parabola, the rules change. Now you need 3 points. What you need is a left point and a right point and your vertex. Okay? You need a vertex, your left point, and your right point. So you're going to need a vertex, this point here, as well as 1 point on your left and 1 point on your right. Once you have that, then you can say, well, the pattern looks something sort of kind of like this. And that's what you're going to need in order to graph your parabola. Now, I'll show you a little later on how to get these 3 points, but whenever you're graphing, that's what you need. Anytime you're graphing anything, parabolas, polynomial graphs, or lines, you always need to know what your key points are. So again, please make sure you know that you need 3 points, your vertex, left point, right point. I have no idea why I formatted this so terribly on top of my PowerPoint. Good job, Mr. Mori. All right, moving on. Using parabolas. Parabolas are very useful, or very well often used inside of word problems. And so let's jump into a practice word problem. This word problem here is the amount of new viewers on Mr. Morimoto's videos after hours from being posted. X is the hours, Y is the new viewers. So my left to right, that's telling me how many hours passed. My up down, that tells me how many new viewers I had that hour. So let's look at this parabola. It says that, hey, look, Mr. Morimoto posted it. All of you guys were on it. You're watching it. But then after this point here, a lot less people watched it. Maybe only the people who slept in late, or the people who procrastinated are watching it at that point. So obviously there's going to be less of them. But again, that's kind of what this is saying. We're saying that the new viewers started getting more and more and more. Then after it reached this point here, there started being less and less and less and less viewers. Now, I know there are points down here, but you can't have negative new viewers unless something really screwy happens. So that's something we always got to watch out with word problems. Does our graph make sense, and how do we interpret it? So let's show you guys some really common questions. So one of the most common questions you'll ask is, which hour did Mr. Mori have the most new viewers? Or whenever you're doing parabola, they'll always ask you, what's the most that this happened? Or what's the least that it happened? Because your vertex, your turnaround point, is one of your key points. So because of that, it's going to say, when did I have the most new viewers? And in that case, that's right here. This is the top. This is the most new viewers I had. And the most new viewers I had happened at 1, 2, 3, 4, 5. So at 4 hours. So when did I have the most hour, or which hour did I have the most new viewers? 4. How many hours after the video is posted did no one else watch it? Well, after this point here, then it just goes back to 0. So I had 0 new viewers. So when did I run out of people watching? At this hour here. So if this is 5, 6, 7, 8. So after 8 hours. Okay. From hours 1 to 8, which hour did the video have the most views? Now again, my up down, that tells me how many new viewers I have. Is this when I had the most views? No, it's not. A lot of times when you hear most, you want to say, oh, it's at the top, but these are new viewers. Just because I have less new viewers doesn't mean I'm getting less views. I'm just getting less new ones. So that means did I have the most views? Well, after 8 hours, because you can't unwatch a video, unfortunately, sometimes. You can't get your life back like that. All right, Now the last one, I'm going to hide my face because I'm blocking it. It says, when did the video start getting less new viewers? And then we started getting a bunch more. Then after we reached the most new viewers we got in a single hour, then the amount of new viewers started turning around. And so when did the video start getting less new viewers? After 4 hours. Again, this is another very common question where they'll ask you, when does my graph turn around? When does it start coming up? Like, oh, what was the lowest that it happened? When did I start coming back up? When did you turn around? These are really, really common questions. Again, some of the most common questions that you get is number one, when did you have the most or least? Or number two, another way they phrase that is, at what time did it start turning around, or did this change? And that's when you're kind of looking at that turnaround point. And again, if you remember, the turnaround point is called your vertex. Okay, in summary, parabolas are made from having a power of 2 in the equation on a variable. Second, they look like user rainbows, and they often asked when things like speed up. Oh, when did it start, the new views start slowing down? Oh, when did they reach the most new views? And they also asked about maximums and minimums, okay? That's the main thing with parabolas. That's part 1 of our video. We're moving on. All right, moving on. This is our next one. We're gonna talk about how to solve quadratics using something called zero product property. Now, here's what we got. When we're solving quadratics, basically we can't just solve them normally. If I gave you something like this, x plus 3 equals 0, it's easy to just get x by itself. You just minus 3 on both sides. You get x all by itself, so we have x equals -3. However, if I have something like this, x squared plus 3x equals 5, then now you can't just solve it easily, because you can't just ignore this x here. And if you wanted to get x squared by itself, you would say x squared equals 5 minus 3x, but you can't combine these two because they're not like terms. So I've not taught you how to solve them just yet. So what we're gonna do is, this is the way that you're solving it, or at least one of the ways in this very specific, what we call factored form, and that's something called zero product property. Zero product property sounds impressive, so if your parents ask you what you're watching a video about, is about zero product property. And what zero product property states is this, that numbers that multiply together or form a product of 0, at least one of them has to be 0. There's no way that none of them are 0. One of them has to be 0. I don't know which one, but one of them has to be 0. So here's what we got. A times B times C equals 0. Again, these are all variables. I don't know what A is. I don't know what B is. I don't know what C is. But I can tell you for sure that at least one of those has to be 0. One of those has to be 0. Maybe all 3 of them are 0. Maybe 2 of them are 0. I don't know. But all I know is that A equals 0. Or maybe B equals 0. Or maybe C equals 0. I don't know which one. Could be all of them. But all I'm going to say is that's what I know. I know at least one of them is. Now we can do the exact same thing with our equation here. We're saying this number times this number. Again, if there's parentheses, we think of it as one number. This number times this number equals 0. I have a product that equals 0. I don't know which one's 0, but I know one of them is going to be. So that means x plus 1 should be equal to 0. Or maybe x minus 3 is 0. Which one is it? I don't know. It's one of them. And so all you do is you just say, I don't know which one it is. So we're going to solve each of them separately. So you focus on one. X plus 1 equals 0. How do I solve this? X equals -1. Again, you guys should kind of know by now how to get x by itself. Same with this one. X minus 3 equals 0. So that means x plus x equals 3. These are my two options. So when I ask you, how do I solve this? The answer is, well, the answer is going to be one of these two. I don't know which one it is. Could maybe both of them work, but this is what one of them. These are your options. Choose one. So that's how you're going to do it. So if I ask you how to solve this quadratic from this form, you're going to use zero product property. Now what zero product property states again, you multiply a bunch of numbers equal to 0. One of them has to work. So let's kind of do another quick example. I have two numbers here, x minus 3 times by x equals 0. Again, I'm saying numbers because if they're in parentheses, we think of them as one number. So I have number times number equals 0. Hey, what do you know? Zero product property works. That means that x minus 3 equals 0. Or x equals 0. I don't know which one it is. One of these are going to work. So then you just solve both of them. Well, x equals 0 is already solved. That's nice. And x equals 3. Done. That's it. So if I ask you to solve for x, your answer is x equals 3 or x equals 0. Just pick one, Mr. Mori. So give me both of them. You're not allowed to pick one. You're not allowed to just say, this is the one I want. You have to give me all of my options, and then I'll decide which one I want. But you're just going to give me everything. Okay? So last example, this is one of the most common mistakes. It's called zero product property. Zero product property. The reason it's called zero product property is because you're multiplying things to get zero. This looks exactly the same as this last one, but instead of equaling 0, it's equal to 2. You cannot just say x minus 3 equals 2 and x equals 2. It doesn't necessarily work that way, because zero product property works because the only way you can get a 0 is by multiplying by 0. But you can get 2 a lot of different ways without multiplying by 2. You can say 1/2 times 4. You could say 1/3 times by 6. There's a lot of different ways, so you cannot use this. This only works for zero product property. So again, if it's not equal to 0, you don't want it, cannot do it for now. Okay? All right, in summary, you solve quadratics using in factored form using what's called zero product property, which means that you split the factors into their own equations and just solve each of them individually and give me my options. Couple things to watch out for. It only works if it's multiplication. Now again, I know there's like a plus sign here, a minus sign there, and I know there was like a minus sign there, but again, since they're in the parentheses, they're protected, so it should just be multiplication. And secondly, it only works if it's equal to 0, like that last fake example I gave you. If it's not equal to 0, you don't want it, you can't use it. Okay, that's the end of part 2. We're moving on to part 3. Okay, part 3. This is how we're going to graph quadratics. Now, this is a little bit irritating, but like I said in the beginning, you need 3 different parts. There are 3 parts you need. You need your vertex. You need 1 point on each side of your vertex, one on the left, one on the right. So let's practice graphing this. So first thing you're going to do is you're going to find your roots, or you're going to find your zeros. If you remember, the way that we do this is we just say roots are wherever your y value equals to 0. So that's what we're going to work with. So let's show you where this is. So step 1, you're going to find your points. The points that you're going to use in this form is wherever y equals to 0. So we're saying y equals to 0, so we just change this y equal to 0. Just like when we did linear graphing. Just pick an x, plug it in. This time we're picking y equals 0. It just makes life easier. Make y equal to 0. The reason we want y equal to 0 is because now that y equals 0, hey look, I have the factored form and we can use zero product property. So what are the things that multiply to give me 0? 1/3 equals 0, or x plus 1 equals 0, or x minus 5 equals 0. One of these are going to work. Now, obviously, 1 doesn't work. 1/3 will never equal 0, so we can just ignore that and just focus on our variables over here. So x plus 1 equals 0. Where is that going to happen? Well, it happens at x equals -1. X minus 5 equals 0. Where does that happen? At x equals 5. So we have 2 options here. We have 2 points, -1, 0, and 5, 0. Now the way I got my 0, again, the way I got my 0 is we started by saying, I'm going to force y to be 0. And that's where I get these points. My x value is -1 when my y is 0. My x value is 5 when my y is 0. Okay, you have 2 options now, not just 1. Okay, now you have your 2 points. Finally is finding the vertex. And this is where it gets a little irritating. Basically, because like I said earlier, parabolas have that symmetry, your vertex is going to be in the middle of your roots. Okay, the vertex is going to be in the middle of your roots. Now what I know is my x value of my roots are going to be -1 and 5. Let me just double check that. Yeah, -1 and 5. My points are going to be -1, 0 and 5, 0. So the question is, what's the number in between -1 and 5? And the way you do that is you find what's called the average. And the way we find our average is by just adding up these 2 numbers and dividing by 2. So -1 plus 5 divided by 2. So -1 plus 5 is 4. Divide that by 2. And then that's going to give me 2. So this here is your middle x. So now you know what x is. How do you figure out what y is? Just like always, plug it in. So we're going to write y equals 1/3 x plus 1. Sorry, the reason it's 0 is I forgot to take it off from when we did the roots. X plus 1 times by x minus 5. But I know that the x that I need to use is 2 and 2. So we plug that in. Y equals 1/3 3 times -3. 2 minus 5 is -3. Then we solve this out. Y equals, how do we multiply fractions to whole numbers? We just multiply the numerator. We put it over 1, top to top, bottom to bottom. So we're going to get 3 over 3 times by -3. Wait, but what's 3 over 3? That's just 1. So y equals 1 times -3, which means y equals -3. Now again, it looks like we did a lot of work here, but really, if you're quick with your arithmetic and you're good at multiplying fractions and dividing fractions and simplifying, this is super, super quick. This can all be done literally in one step. That's why you want to make sure that you're good with your multiplication and division, not just, I'm okay with it, but you need to be good, okay? Wink, wink, nudge, nudge. You guys are at home. You do have your computers. Open up Google and use a calculator. Use the Desmos calculator app. I don't want to say I don't care. It'll help you in the long run if you know how to do it. But if that's what you're struggling on, then I'd rather you get over that hurdle and just make sure you figure this out. All right. So now that you have your 3 points, oh, look. I put all of your 3 points so nicely over here. So now that you have your 3 points, I'm going to put a V over my vertex because that's my very, very, very important point. So first thing I'm going to do is I'm going to graph my vertex, and that's 2, -3. Now, if you guys remember, 2, -3 says we go 2 to the right and 3 down. That's this point here. Then next I have -1, 0. That's 1 to the left and 0 here. And I have 5, 0, and that's right here. And I'm going to put a V next to my vertex so I don't forget which one that is. And then after that, all you're going to do is you're going to start at your vertex, and you're just going to kind of make this U shape going up through your 2 points. And that's how you sketch your parabola. That's it. Done. Quick? Not necessarily. Terrible? Not really. Hopefully, because it's really similar to how you guys did your lines. Finding points. It's just now how you find your points is a little different. So in summary, whenever you're asked to graph from factored form, use your factor to find the 2 roots. Set it equal to 0. Set y equal to 0 and solve for your x. That gives you 2 points. Then you find the vertex by finding the middle or the average of the 2 roots. Once you have your 3 points, just connect the dots and then make sure the bottom or top of your U or rainbow is at the vertex. Okay, sorry that was a bit of a long video. Lot to cover here. If you have any questions, let me know. Again, check through the time steps. Maybe you understood graphing, but you just really did not understand zero product property. Go back to the zero product property and check that out. If not, see you guys later. Have a great weekend.